Welcome back, everybody, to the Across the Sky podcast, our Lee Enterprises National Weather Podcast. We are talking about the winter of 2022 and 2023. You listened to part one last week. Now we have part two for you this week, and we are joined by our same guest here, Judah Cohen, the Director of Seasonal Forecasting at AER in Massachusetts. Judah talked to us a lot in the first part about how he just got interested in weather, his love for snow, and how he moved out of New York City at the best time because he left when they had their snowiest winter on record and now is over in the Boston area. So Judah, welcome back on here for part two. We talked about the polar vortex already in part one here. One of the things that is unusual as we go into this winter is that this will be our third La Nina in a row. La Nina means cooler than average waters across the equatorial Pacific. So pretty much look at Peru, draw a line to the left on the map, and that area is cooler than average. Tell us what you're seeing with La Nina, and doesn't even mean anything for the winter here that we're in a third consecutive La Nina. I already see you smiling a little bit, so I'm curious to hear your answer.
Yeah, so again, La Nina is the first predictor, let's say, used, and it's still the most heavily relied on predictor for making winter forecasts. So, everything certainly it's a good place to start, even for me, who's not really focused on El Nino Southern Oscillation. So we have, so when you have the waters in the equatorial Eastern Pacific are warm, that's El Nino. This, for the third winter in a row, we're going to have cold temperatures in the Eastern Equatorial Pacific near, off the coast of South America there. So that's called La Nina. So it has a very distinctive kind of character to it. When you look at the relationship between the water temperatures and our weather, so La Nina, the cold phase, we tend to have colder to the north and west across North America. So that includes the U.S. So kind of the northwestern quadrant of the U.S. tends to have a colder winter. And then as you move south and east, it gets milder. So the southeastern U.S. tends to have a milder than normal, warmer than normal winter. Coupled with the temperature comes also a very kind of distinctive storm track. So El Nino, the storm track that shifted south, close to the southern U.S. and across the Gulf of Mexico, and then with La Nina, the active or the storm track is kind of shifted north across the northern U.S. So you tend to get wetter in the Pacific Northwest and the Great Lakes, maybe a little bit into the northeastern U.S., along the U.S.-Canadian border. So, and if you look at most of the forecasts, certainly the ones that are based, come out of the government forecast center, so NOAA here in the U.S., but similar to other forecast centers across the globe, they all have a very similar pattern. Colder to the north and west, milder, certainly, I think they're also milder east of the Rockies, pretty much. And then that precipitation pattern that is so strongly associated with a La Nina pattern. I don't know. It's only happened when I look again, and so it's not my specialty. But I think I am only familiar one time it happened before 74 to 76, where we had three La Ninas in a row. Maybe the closest it came to happening again, I think, was 2013 to 2015, but didn't quite make it that last year. Not a lot of analogs to go off. I wouldn't feel comfortable making too many kind of projections based on one sample size one. I think that's certainly a very is what I'm looking for. That's a credible forecast. For the most part. Again, my whole my career, I try to argue that that you can't live on, man cannot live on ENSO alone. Let's try to bring in that polar vortex, at least get some increase the number of variables we're looking at. And I do think that the polar vortex will trump ENSO if it's very active. Our understanding of the polar vortex and its kind of relationship with our weather is a younger science, not as well established. So certainly a lot of it's relatively new. I'd certainly call it more speculative than relying on ENSO, but trying to push that envelope. If you don't, it's like, I don't know if any skiers here, if you're not falling, you're not learning. If you're not making mistakes, as well, I think you're not learning. So you always learn more from your mistakes than from your successes. Because when you're successful, you don't you don't feel like you need to change anything. But if you make a mistake, especially if you make one publicly, if you put out a forecast and it's public, and people will let you know on Twitter, certainly they if you blow the forecast, they won't be shy about reminding you of that.
Yeah, Judith, that's for sure. I know we've all been reminded when we've made the mistakes. But as you alluded to, the El Nino Southern Oscillation, that's really the big driver, the overwhelming driver. But what are some of the other things that you've been looking at that have become a little more robust in the last 10 or 20 years of doing these sub-seasonal to seasonal forecasting? We talked a lot about the snow cover in Siberia in October. I mean, we understand to some point why the jet stream does what it does in a La Nina situation, how that basically feeds back or cascades into a preferred jet stream track, thus cold in some areas, drier and milder in some areas. Could you speak to how that physical relationship might be between the snow cover in the Siberian Arctic compared to what happens downstream ultimately into North America, or is it really just more statistical?
Yeah, so when I first proposed the idea, over 20 years ago, I mean, I was like, I had like people looked at me like I had two heads. Like, are you crazy? Are you kidding me? I mean, how can you go from snow cover in Siberia to our weather in the East U.S.? How possibly does that translate across the North Pacific and so on? But I think it was certainly given the kind of the strong skepticism. I've tried very hard to found it in physical ideas and physical reasoning, and I think it makes sense. So it gets a little complicated. I try to keep it as simple as possible, but again, going back to, I use that analogy at the top. So when a polar vortex is in its normal state, is strong and stable, and that polar vortex is has a very fast, quiet rotation and keeps all the cold air close to the center of the circulation or rotation, and it's milder here. So that's a normal state. That's a typical state. And if you want to get colder weather, you kind of have to disrupt that very tight rotation of the polar vortex and a very circular tight rotation. And so the cold air is close to the North Pole. And how you do that in the atmosphere, so like I said about banging on the top, and that weakens it and causes it to wobble and meander. So there are waves in the atmosphere. So people are familiar with the jet stream, right? That's where the jets fly, and the jet stream region is kind of this vast ribbon of flowing air. But there are undulations or kind of waves in the jet stream, and just like ocean waves, they have energy associated with them. So if the wave, like an ocean wave, standing in the surf, and the ocean wave is very gentle and small, right? It's not going to bother an adult human being standing in the surf. But as those waves get bigger and bigger, they have more and more energy. And so let's say it's a hurricane offshore, and these big waves, swells coming in, that's going to knock you down. And so the same thing happens with the polar vortex. If the waves in the jet stream are very small, small in magnitude, so the crest of the trough is almost flat, then it's not, the polar vortex is left unperturbed, right? It kind of shrugs off any of these little waves that come up its way, just like you would if you were standing in the surf. But if those waves, as that wave gets bigger and bigger in the jet stream, or kind of in the troposphere where all the weather happens, then that could really start banging on the polar vortex, right? And then it can really, the bigger the waves in the jet stream, the more likely it is to disrupt that circulation. It's more like the that top banging right into a wall or something. It's really going to disrupt that circulation, that kind of circular circulation that's nice and fast, that tends to keep all the cold air bottled up in the Arctic. And if you get this disruption, it's like that dam burst and the cold air spreads out. So the size of the waves in the atmosphere really determine the behavior of the polar vortex, whether it's strong or weak. Both continents kind of form just a natural, we call standing wave, that are basically semi-permanent, right? They stand over the continent. And we're here talking about different regions. So the Western U.S. is milder in the winter than the Eastern U.S., right? Seattle or Portland, Oregon are probably, close to the same latitude as Portland, Maine, but Portland, Maine is way colder, right? So as you go from west to east across the continents, it gets much colder because weather systems tend to flow from west to east. So if you're in the western part of the continent, you're getting this maritime or ocean influence and the oceans are much warmer than the continent in the winter months. But if you just kind of draw a line of equal temperature across, the same latitude across the continent, so you have North America, but Eurasia is much, much bigger. Europe is mild, right? London is very far north, but it's much more milder than certainly Labrador, Canada, where, same latitude, right? And then as you go further and further east, it gets colder and colder, right? Siberia, a place Siberia, the same latitude as London, but, so much colder. So if you take a line of equal temperature and you go across the Eurasian continent, so it's going to kind of bulge to the north because it's much warmer. So if you follow, let's say, the 0 degree Celsius or 32 degrees, so that freezing line, it's going to go way north over Europe. That's kind of that crest. It's like that ridge or crest of that wave. And then as you go further and further east, it's getting colder and colder. So that freezing line is going to drop further and further south. And that's going to make like kind of the trough of the wave. So snow cover in the fall months, right, is really focused in eastern part of Eurasia. So snow cover has the highest naturally occurring reflectivity. So it's a surface with the highest reflectivity anything that occurs on Earth. So more sunlight gets reflected back into space, that leads to colder and colder temperatures. So more snow, colder temperatures, right? And again, the snow tend to be focused in the east, so it's cooling. So you have a very expansive snow cover that's cooling the cold part of that thermal wave. Let's talk about, right? It looks like a sound wave, the same thing. And so it's cooling the trough or the cold part of the wave. Now, I talked about sea ice. I said this a part of that the area, the region of the sea ice that's seeing the most melting and it's most impactful on the polar vortex is over towards Europe, near Scandinavia and northwest Russia. That's where the ridge or the warm part of that wave across Eurasia. So snow and ice, so more snow and less ice, since they're juxtaposed, right? The ice is happening to the west and the snow is happening to the east. They kind of, we talk about, I don't know, physical term, constructively interfere with this naturally occurring standing wave. They amplify it or make it larger. And the bigger the wave across Eurasia, the more likely it is to then disrupt the flow around the polar vortex. So that was a little bit long-winded, maybe a little bit complicated explanation,
but a good one. No, I mean, it is complicated. I mean, that's the thing. If it was easy, we'd have all the answers already. That's part of science, is going back and, as you said earlier, making mistakes, learning from them, making corrections, seeing what you observed, and then moving them forward. So that's good. I mean, it's important to look at what's going on in other parts of the world for sure. We're going to take a little bit of a break, then we'll come back with Judah and the rest of the Across the Sky team, and we'll look a little more about what those signals are telling us for the upcoming winter.
All right, welcome back, everybody. We are here with the Across the Sky podcast, along with Judah Cohen, and the time is here. We have hinted at it at the first half of this podcast today, but it is time. I almost feel like I need a drum roll for the 2022-2023 winter outlook here. Judah, let's start off with the beginning of our cold snow season. We'll talk about November into December. What are we thinking here across the United States?
Yeah, so I'm a big believer of the trend is your friend. I think that's an economic term, people in Wall Street like to use, but I believe in that for the weather as well. The trends tends to be hard to beat sometimes, but I'm not saying it's absolute predictor. But there's very strong trends here in the U.S. that the winters start off very mild and then trend colder and colder relative to the long-term history, not just might say, well, yeah, it's always cold in February or something like that. But relative to February there's been this cooling trend, and December is relative to December has been a warming trend. So I never say never, and now that I'm on it and on the record, it'll probably not happen. I tend to think if we're going to see, I make the joke that Martin Luther King weekend should be the official start of winter, not December 1st or December 21st, because it seems like, we're not getting really, Christmas is almost, people, certainly some people like snow, some people hate snow, but it seems like everybody's in agreement on Christmas Day. They want snow. So, but it seems like it's getting harder and harder to get that white Christmas that so many people are dreaming or desiring. So more likely to get a white St. Patrick's Day than a white Christmas, it seems like to me. So it starts out very mild and then kind of lingers on, or certainly gets cold. February is a very impressive cooling trend, and down the center of the U.S. So Tulsa would be kind of right there in the core of that. Less so on the coast.
So we're saying, you just said Trez is your friend, and you're pretty good with these little sayings here. I think you had what'd you say? A man can't live on Enso alone. I like that one. But for the first couple of months, so we're talking about November into December. Generally, you think. Go ahead.
So we talked about in the first part stretch polar vortex events. For some reason, they seem to happen a lot in November, less so in December. So, and I feel like we're more likely to get kind of a cold month relative to normal in November than December. So there are signs. So here we are, we're recording this. I don't know when it airs. We're recording this kind of end of October. That I've been, pushing this on Twitter. We'll see now, this will be a big fail on my part, but I feel like that we're looking at a stretched event. And right now it doesn't look very big, but a stretch polar vortex, which kind of favors cold east of the Rockies. Models are not showing any sign of that whatsoever. They want to keep any cold in Western North America. It seems like we've seen more of these type of events in November, and somehow they kind of go on hiatus for December and then come back in January. So I think, it's a better chance of getting cold relative to normal, okay? Because it's hard to get a colder November than December. I mean, probably not impossible. I think maybe it happened in 2014, but yeah. So I think it was a kind of cold relative to normal. I think November is a better shot than December. I mean, again, I could be wrong, and I have nothing really good. I don't have that visibility, but the trend, again, I'm reluctant to go against the trend. I mean, and sometimes it doesn't work out.
Well, I'll tell you what, at least I know here in Jersey, November, at least in the past 5 years that I've been, down here in South Jersey, November's been below average more than most, and December's been above average. So kind of tying into your
right. So that's just so that's the trend. I mean, you're verifying the trend that I'm talking about. So I think overall, I tend to think we're going to see a milder start to the winter. But if there is some colder period, I think it's more likely in November than December. But I mean, this is based on kind of statistics or recent history more than any some great physical insight on my part.
All good. Well, that's why we're here with you, to hear what your thoughts are. And then now let's get into the core of winter. You joked about Martin Luther King Day, but once you get into late January into February, that is when winter is really at its peak. So, across the country, what are your thoughts for that period of time?
Yeah. So, and there's again a physical reason. So these big disruptions of the polar vortex tend to happen in January and February. They really don't happen in December. So I think, what we're seeing, when you take the winters in summation, what we're seeing is this climate change is leading to milder temperature. The oceans have been absorbing all this heat, and they tend to release it in the wintertime. So it's definitely a strong forcing to make for a milder winter. And I would say in the absence of any kind of involvement of the polar vortex, that's just going to, kind of rule the day. That's going to be the 800-pound gorilla. I mean, it's going to be hard to overcome that. Then the polar vortex really only gets going as far as influencing our weather. I mean, the polar vortex is around right now. It's only a wintertime phenomenon. There's no polar vortex in the summer. It goes to the southern hemisphere for our summer months. So it's around, but it doesn't really get really strongly involved with our weather until January and February. And so as the polar vortex is maybe more likely to break down in those months, I think, so we have, mild start because the polar vortex is not so involved. And then in January, February, we're more likely to see, a kind of return to a cold, extreme cold period or a disruptive snowstorm. And so, it usually takes 2 weeks for that information from that signal to get from the polar vortex down to the surface. So that's why it's more like mid to late January before we really see the impacts there. If we're going to see kind of a colder winter, I always kind of favor it happening, back-ended, not front-ended. Again, things can change, and certainly this is not based on a lot of physics, what I'm talking about, but it's kind of just my own experience and my own understanding of what are the important factors. Yeah, so I there is going to be like a period of really impactful winter weather. Again, I think it's more likely in January, February, maybe lingering into March, more so than December. For sure.
And Judah, is there any part of the country that stands out to you as perhaps should be concerned about seeing a potentially harsh winter? Any area that seems like could be affected by the polar vortex the most this year? Is there any kind of area that you're watching that could have the worst conditions as far as the coldest and snowiest conditions?
So, I mean, I did talk about the Siberian snow cover. It's been very lackluster this month. I mean, it started out gangbusters. It was like very high, maybe the highest. It started that month, the highest number, in 20 years. And I was looking for this big number, and it just then flatline, which never ever happens. I think it'll come into normal, so I'm probably not the best predictor. But let's say maybe that has me biased, thinking more milder. So the more snow in Siberia favors colder in the east, maybe cold. So less snow maybe favors milder in the east, but maybe colder in the west. They tend to go in opposite directions, the eastern and western U.S. It's rarely cold everywhere or warm everywhere. They seem to be kind of half a wavelength. I don't know, not to get too complicated. Out of phase. The west and east tend to be out of phase. So let's say with not much of a signal from the snow, so then certainly rely more on the ENSO, La Nina, which favors colder to the west, warmer to the east. And especially in the southern U.S., I think La Nina has a bigger influence. Again, northern U.S., I'd certainly look for the polar vortex to be more impactful. But right now, not getting strong signals. Sea ice, I think, is more favorable. We're kind of disrupt because it's looking like the big anomaly is going to happen in that North Atlantic sector that I described previously. That would favor a weaker polar vortex and some colder weather. But so we talked about these very large disruptions that are all kind of lumped into these sun stratospheric warmings. And I said, I've been really focused recently on these stretch polar vortex events because they can be very, very impactful on the U.S. east of the Rockies, and they tend to have their strongest signal right down the center of the country for different reasons. I think maybe if we get involvement of this weakened or disrupted polar vortex, it's going to be more of the stretching type, and the stretching type has this strongest relationship right down the center of the country. So if there is a kind of cold period or some cold weather, I think down in the plains into the Great Lakes, that's where I would look for maybe the most likely to see really impactful severe winter weather. Based on not only La Nina, which I do think kind of shifts the cold further west, as opposed to El Nino, where the cold gets shifted east, if the polar vortex is involved. I do think kind of does help to center where the cold will be, the biggest, core, the departure from normal. So if my kind of instinct, and maybe it's not much more than an instinct here, that we will see there will be these stretch polar vortex events, especially, maybe earlier on. Sometimes these stretch polar vortex events lead or kind of a precursor to a larger disruption. So, that's certainly possible. But I don't see that happening, in the early part of the winter, at least not yet. Yeah. So I would, so again, I think, I don't really disagree with these La Nina type forecasts that show, my overall mild for much of the eastern, 1/3 or 2/3 of the country right now, because the Siberian snow was so lackluster this year. But, if it is going to be, if there are periods or if there's a region that might actually see an overall cold winter, I would favor right now, right down the middle of the country. Certainly more Tulsa than Richmond.
Well, I like snow and everything, but I do enjoy a milder winter. Again, for me, the biggest concern is if you get a cold air damming situation, then you have to fight against the ice. But I think the other thing to bring forward, Judah, is that I think oftentimes just communicating what we do know about a winter or what we think about a winter in general terms doesn't necessarily mean, it doesn't tell you a lot about what's going to happen on, January 30th or February 15th. That we need to speak in these general terms. Like you said, cold, meaning colder than average, colder what you become accustomed to. And as you spoke, we've got if there was going to be a place that had especially cold weather, it would likely be near the nation's midsection again. But if I'm understanding you right, there are no signs of massive repeated cold outbreaks across North America this winter. Obviously, there will be spells, but there's no signal out there that like, oh my heavens, it's going to be bad.
Not right now. From
Okay.
what I see,
Okay.
not right now. But that could change. I mean, I
Sure.
don't come out with an official forecast, and I do post it on the blog. Or we don't put it. So I should say we, because it's not my company. But we don't come out with an official forecast until November, and it will be published, on my blog at the end of the month, so people can see, what the final thinking is. But looking at these early, and it's early for me because the month hasn't ended. I don't have all the data, not the snow, not the sea ice. But from what I see early, I'm definitely leaning, milder, but that could change. I have a colleague who works with me on the forecast, says, the trend is your friend. I mean, I always start out very mild, and as we get closer to winter, maybe panic sets in and I start getting the forecast turns colder. But we'll see what the final numbers are. And I don't know if Joe ever mentioned on this podcast, he has a very good friend, Dave Robertson. He's the gatekeeper there. He has all the
My
snow
weather
data.
dad.
Why?
My weather dad, Dave Robinson. I was actually just texting him because he has laryngitis as we speak.
Okay. Well, anyway, but he's the gatekeeper of that snow data. So I'm going to wait for him to put it out, and that'll be the numbers we'll put into the model here. We calculated, ourselves here, but it's kind of really an estimate, and we tend to lowball the numbers, to be honest. So usually the number I come up with tends to be lower than what actually Dave finally puts out. So that I don't know why that is, but it's a bit of an archaic way how they calculate. It's not intuitive, trust me. But yeah, so maybe I'm really underestimating how much snow there is. And I will say again, as I talked earlier, this snow everywhere is not the same, right? It's the snow in eastern parts of Asia that are really critical. And there is studies, not my study, but there have been recent studies saying less snow in western part of Eurasia or Western Asia. Actually, so you have less snow in the west and more snow in the east. That is actually the optimal pattern for disrupting the polar vortex and bringing cold winter. So, we're not that far off from that pattern. So I could be completely underestimating, the influence of the snow. I don't know if you told me, again, this is a technical term, but I think it's important. High latitude blocking. I mean, at the end of the day, like I talked about that wave, right? So if you have that crest of the wave across Western Eurasia and the trough of the wave across Eastern, that is optimal for disrupting the polar vortex. And it looks like we're getting into that pattern now. So can't last for a day or two. That will not make a difference. But if it persists for multiple weeks, a month or 4 to 6 then it could do real damage to the polar vortex. And if that situation occurs, and I have no idea of knowing that, then all bets off on the mild winter forecast. So, but that's in my blog, on Twitter, even today, I really want to kind of focus in on that, this high pressure ridge. It's called Euro-Scandinavian blocking. That's what meteorologists call it. But that crest of the wave that builds across the western part of Eurasia, and then kind of helps deepen that. So same, in Eastern Asia, then that is optimal for breaking down the polar. Where I will certainly get all excited on Twitter if I see that kind of feature persisting. And we have something similar here across North America. We have that big heat dome. I don't know, I shouldn't use heat dome in the winter, but you got that high pressure, dry weather in the Western U.S. We talk about, people say, oh, look how warm it is in Anchorage. It's warmer in Anchorage than Atlanta or something. And we get that same kind of pattern here across North America with that big high pressure ridge to the west and that trough, cold trough, wetter trough, maybe some snow in the east. That happens across Eurasia, but on a much larger scale because the Eurasian continent spans so many more miles or longitudes than North America. So that's what I'll look for. Now, bringing back to La Nina a little bit. So La Nina is thought to, like I said, so the optimal pattern for disrupting the polar vortex is that high pressure ridge across Western Eurasia with this trough to East Eurasia into the North Pacific. And that's optimal. La Nina is thought to actually build a ridge in the North, a high pressure ridge in the North Pacific. So it interferes with that wave pattern that's so favorable for disrupting the polar vortex. That's why in the literature, there's some controversy, but I think everybody's kind of coming to a consensus that La Nina favors a stronger polar vortex. And it's because I think it interferes with this kind of wave that is so favorable we're disrupting the polar vortex. And I don't disagree with that. But it won't be, so it's hard to get, I think, a bigger disruption of the polar vortex, but I think that is still very good for polar vortex stretching. And it's one of the kind of, why it's shaping my thinking here. Let's, look out for those stretch polar vortexes this winter.
Okay, Judah, to finish up the winter forecast, we talked about November, December, we talked about January, February, the heart of it. But now let's talk briefly, and I know this is really far out, so this might be a bit of a stretch, but can we talk about March and April, which is usually the time of year people are worn out from the cold, there's been snow, and people, of course, that's when the groundhog comes in. And will winter end early or will it linger? What are your thoughts about March and April and what's going to happen there?
Yeah, so it does seem to me like there's been this seasonal shift in winter. So it's milder at the start and kind of colder, kind of lingers longer towards the end. And I think, again, it has to do with these polar vortex disruptions. We get a big polar vortex disruption later in the winter, its impacts is for many weeks after that. So it can, kind of bias the weather colder and snowier, into March, even sometimes into April. So that, I can't see that now, but that's what I'm looking for. We have, or sometimes when the polar vortex, it disappears, goes away in the spring. If it goes out with a bang, we tend to get kind of colder weather with it. If it goes out with a whimper, it tends to be milder. So that's also, I think, very influential. And we've been having more of these, more dramatic endings to the polar vortex season. And so I think we've kind of seen like these cold Aprils, even into May sometimes. So that's what I'll be looking for. I have no idea. I do think La Nina, if there's a big disruption in the polar vortex, tends to push it off to the second half of the winter. So, maybe if we get a big disruption, but again, our trend is also very much influencing my thinking. And so I tend to bias, if there's going to be cold weather, it's towards the second half more so than the first half. So March and April is a long ways. We haven't put out forecasts. We're not going to put out a forecast anytime soon for those months. And I don't have any insight, but that's what I'll be looking for.
Well, Judah, we appreciate having you 2 weeks in a row here to talk about the polar vortex, the winter to come. I think we peppered around the country enough here. I know we have a little bit of a northeastern thing going on between Sean, you, and me, but I think we were able to get around a decent amount here. And whether you love snow or hate snow, it is just part of the winter season that we have here in the United States. Judah, again, we can find you on Twitter at Judah47. You can also type in Judah Cohen blog. He puts out blogs that are publicly available every Wednesday. You can also sign up and pay for the blogs to come out 2 days early. So if you want to pay and get them on Monday, you can do that. If you want them publicly, you can wait 48 hours and get it on Wednesday. Judah, thanks so much for the time. I appreciate it.
Well, thank you. Thanks for having me on, plugging the Twitter and the blog. Greatly appreciate it.
Absolutely.
A lot of fun.
Absolutely. Always a good time with you, Judah. Hope to see you in person soon. We're going to toss it over to Tony Rice for our astronomy update, and then we'll come back and recap the Across the Sky podcast.
Looking beyond the atmosphere, here's Tony Rice with your astronomy outlook.
This week begins with hurricane watches as newly named subtropical storm Nicole is forecasted to impact the east coast of Florida. NASA's keeping a close eye on this one as it could yet again affect the next launch attempt on November 14th of the Artemis 1 mission to the moon. The 32-story SLS rocket was rolled out to the launch pad early Friday morning after it had been rolled back to the vehicle assembly building in late September to ride out Hurricane Ian. Rollback isn't expected this time ahead of Nicole, at least for right now. According to U.S. Space Force Launch Weather Officer Mark Berger, sustained winds of 25 to 30 miles an hour and gusts approaching 45 are what's expected at the Cape. And that's well within the constraints for the rocket sitting on the launch pad, which was designed to withstand up to 85 mile an hour wind gust. The National Hurricane Center, as of this morning, was putting a less than 1 in 20 chance of sustained winds approaching those damaging levels. But if things change and NASA does decide to roll the rocket back, it'll happen well ahead of forecasted landfall. You see, it takes 6 to 12 hours to complete the 4-mile journey back to the vehicle assembly building. And that trip is limited to no more than 46 mile an hour peak winds. And there's other weather criteria that must be met before a rollback would be attempted. less than 10% chance of lightning within 20 nautical miles, and no more than 5% chance of hail. Looking ahead to November 14th, the wind criteria is a bit less forgiving. Winds can't exceed 44 miles an hour at 450 feet above the launch pad. That instrumentation is mounted on the 600-foot tall towers that surround the launch pad and make up the lightning protection system. That's your astronomy outlook. Follow me at RTP Hokie for more spacey stuff like this.
Thanks, Tony, for the astronomy shout out. And everyone, how did we feel about the winter outlook?
Well, I feel like we got a cold winter coming here in Tulsa. That's what I heard.
Well, yeah, I mean, yeah, he pointed out Tulsa a couple of times.
I like it when it gets cold. Like I like a couple good snowstorms here. It's nice, kind of shuts things down for a little bit.
Now, wait, let me ask you, because you lived in Denver and Knoxville. And I was saying, when you were in New York for that semester, were you there during the winter? Did you get to experience a New York winter?
No, but but like you said, I did live in Denver, and Knoxville is but Denver, I mean,
right.
We got our fair share.
Denver can still on Labor Day.
Yeah, true.
My big takeaway is that he said, follow the trend. And so here we are, third year in a row with a La Nina. So I think the best indicator, and that seemed to be what I was getting away from it, is look at the last two winters and what happened. And we started pretty mild. We might get something late November. We'll watch out for that, because we have seen that where it seems like, this is going to be bad. We're already really cold and getting snow in November. And then suddenly in December, it kind of disappears and it warms up again. And then a lot of people get disappointed. And there are a lot of people that don't get a white Christmas. That's definitely been a thing the last couple of years. Not many people seeing a white Christmas. And I have a feeling maybe we'll get lucky. A snowstorm will sneak in there at the end of the month before maybe we'll transition into the cold, snowier part of the winter. But I don't know. Right now, it's looking like if you look at the last couple of years, I think a lot of people are going to be disappointed for a white Christmas. But then January and February, things might be changing.
Yeah, I suspect you're right. And I think the longer you do this line of work, you begin to notice that a winter is normally not the same all winter long. There's normally going to be regularly some kind of colder spell and milder spell. I mean, I remember going back into the winter of 1989 and 90, which was the opposite of what's happened recently. It's brutal. It was brutal in December of 1989. Then the pattern flipped. It was mild for the rest of the winter. So I think the thing that always kind of makes me cringe a little bit is if it is cold for a little while, for a week or two in November or even late October, people are like, oh, it's going to be this way the rest of the year. I'm like, no, it really just doesn't work that way.
There are seasons within the seasons.
There really are. And that goes back to, jet stream. And that goes back to La Nina, goes back to the dreaded polar vortex, sudden stratospheric warmings, snow cover in Siberia in October. All that stuff's related. And yeah, man, it's hard. It's hard kind of. And then you want to try to downscale that into what's going to happen the third week in February for this trip I'm planning. Good luck, man.
I am planning a ski trip sometime in January or February in maybe Vermont. But Vermont's usually pretty good with snow. So, if you're running low on snow in Vermont in the January, February, you got some bigger problems.
Indeed.
Here on planet Earth. All right. So we're going to wrap it up here for our Across the Sky podcast. Thanks for listening to both editions here, both last week and this week. Hope you enjoyed it and hope you learned a lot too. A lot of weather learning we had over the past 2 weeks here with Judah. So incredibly intelligent person, and we're happy to have him on. Looking ahead into the rest of November, it's a November to remember here because we had our winter weather outlook. And then as we go into the 21st, we're going to have Nick Underwood, another big guy on Twitter. Happy to have him on. He is a hurricane hunter. He's going to come on for the 21st, and then the 28th, we are going to do the top 10 weather songs of all time. We still need a guest for next week. We'll get that to you next Monday. But overall, it's shaping up to be a very lively November here at the Across the Sky podcast, and happy that you're here with us. So take care, everybody, and we will talk to you soon.